Hi there. So you've asked me to do a follow-up tutorial for the video that I've done before, where I showed you how to plannerize these elements for the dome. And I will have that link to that particular video in the description of this video. Hopefully it makes sense. You'll find, everything in the description. So here in this particular tutorial, I will be doing two things. First one is going to be showing you how to add numbers to the tile so that you know which one is which. And the second one is going to be how to orient these tiles and make them ready for 3D printing or CNC milling or anything like that. So basically how to lay them out flat. Yeah, let's begin, I guess. I've simplified this a bit, so just that we don't need to deal with too many elements. But other than that, I haven't changed any of the parameters from the original tutorial. So here we have all of our elements separated into two parts, right? The papa joints and the mama joints. The mama joints are the red ones, these ones, and the papa joints are the blue ones. So I'll start working with, let's start working with the red tiles first, right? And the way I imagine it is that on the top of each tile, we will have a number engraved into it, like pushed into it, some sort of a number. And I also think that, yes, I think that it would be nice to have some sort of a lettering system as well, that every red tile has a letter A attached to it, while every blue tile will have letter B attached to it, for instance. So we'll do that. So top of the tiles. Okay, let's think. Here this is the moment where we kind of finish up creating the tiles, right? And we join them up, we merge them, and here we have like three components that make up each of these bricks. So let's just take a look at them, right? Let's take a gander at what they are. So these are the joints, okay. These are the horizontal or the vertical, I guess, plates or the perimeter of each brick. And these are, yeah, so this is the top and the bottom. Okay, great. So I do need the top of each of these, so I'm only going to work with this. And yeah, let's begin. So let me just do this real fast. I will just kind of create a surface component. And by the way, this is also going to be a bit more of an advanced tutorial, so I'm not going to explain every single thing that I do, but just my thought process involving those things. So I'll create a surface component just to drag it out and have it separated. And I want only the top surfaces. I don't care about the bottom surfaces. So I will hope that using list item and separating the bottom with the top will give me, yeah, it does give me clean separation. So everything that comes out from I output is the bottom surfaces, and everything that comes out from +1 output is the top surfaces. I can just create a surface component here just to show, right? So all of these are the top surfaces. Great. So now for the top surfaces, I need to add some text to them. What kind of text? Well, I need to count them, right? So each surface needs to get a number. And I can do that by, well, the problem is that I need to know how many numbers I actually want. And here I can see that I want 48 numbers, because here I have 48 tiles, but it's going to be a little bit tricky. So let's do tree statistics. Tree statistics, which will give me the C output is going to be count of branches in the tree, right? How many branches I have, and I have 48. Okay, that's great. I have 48 branches, and I can use that number with series, and I can start counting from 0 48 times, right? and my step size of counting is 1. So the output of series, if I were to check it with a panel, is just, series of numbers starting from 0 and ending with 47. So if you start counting from 0 until 47, you get 48 numbers. Okay, so we have a number for each element. Yay! We don't want just to have a number. We also want to have a letter, as I mentioned before. And the letter that I want is going to be letter A. I'm just going to have a panel, with letter A in it. And I actually need 48 letter A's, one for each tile. So I'll repeat data. I'll repeat this letter. I'll repeat it 48 times. So I'll just use the same count output here, like so. So now I have 48 letters A, and I have 48 numbers. Time to join them up. For that, I will first use merge to get them into one big happy list, and let's see what we get from the merge. Yeah, that's not what we want. And the reason for that is because it just takes the whole list of A's, adds it, and adds a whole list of numbers to the whole list of A's. So basically, first we get all of the A's, and then we get all of the numbers, right, at the end of the list. If I were to graft, that's not graft, that's flatten. No, it is graft, sorry. If I were to graft both of these outputs here, then I get first A is paired with the first number, second A is paired with the second number, and so on. So I get this really nice data structure here. A0, A1, A2, A3, blah, blah, blah. Okay, now I can use text join command and join those 2 lines of text per each branch into one. And with the panel, if I check now, it's, a single line of text, A0, A1, A2, blah, blah, blah. Yay. Okay, so we can use that. I still need to actually have that text as, how do you call it? As geometry, right? As curves. And for that, Ngon's plugin is going to help us out yet again. There's a lot of different plugins that do it, that do text as curves, such as Bowerbird, Fox plugin does that. Does Pufferfish do that? I don't remember, but Ngon is one of them anyway. So I'll be using that, and we will. Oh my god, I don't remember where it is. I'll just write text, and I'll just choose this one: text for laser cutting or milling. Yay! We use that. Asks us for a bunch of different things. Okay, what does it want? It wants a location for the text, right? So we need a center point for each of these top surfaces. That's easy. I have the surfaces. I can evaluate, not a center point, sorry, a center plane. I can evaluate those surfaces. So I'll use evaluate surface with UV coordinates, and I will use a panel with 0.5, 0.5. That's the middle, right? With UV coordinates, it doesn't give me the middle, right, when I plug it in. The reason for that is because this is not parameterized, so I need to right-click on the S input and choose reparameterize, and now it's fine. Now it gives me the center points and also center planes. The plane is the important part, right? The center planes are located here under frame, and actually I kind of want to do it this way. Sorry, I'll rearrange things a bit. I think these two can go down here, and all of them can lift up. Yeah, I think this is going to be a little bit cleaner down the line. Okay, so frames are basically planes, and that is necessary for the text location because it also gives us the orientation of the text. Text to display itself is just straight up this result from text join. And that's it, literally. We get our text. Notice how it is inverted, right? It's mirrored. We don't want it to be mirrored, so we use flip plane. And we check if flip plane belongs to... No, it belongs to the... God damn it. It belongs to the Fox plugin, and I don't want to give you guys too many plugins to work with. So instead of flip plane, we will use something else. Let's go to vectors, plane, adjust align, plane coordinates, plane offset, plane normal. God damn it. Can I just deconstruct? Okay, let's do it this way. Deconstruct plane, bam. Construct plane, bam. And we do origin will go into origin, and X and Y need to be flipped around. So flip or reverse vector. So X is reversed and Y is reversed, and I think that's gonna flip the plane. It's gonna flip the Z value. We'll see, Z axis. Let's see. Did it work? Wait. Yeah, and are you fine now? No, you're not. Oh god damn it. Does Y need to stay normal? Yeah. Okay, so now it's fine. Now it's fine. So we just flip the x-axis apparently. Okay. So we have that going on. The font is disgusting. I mean, it's great for fast laser cutting for sure, but for what we want to do, it's not that good. We want to have a bulky font. So I'm just going to choose bold to be, I'll just choose toggle, turn it to true, bam. That's it. Font is now nice. And the size of it, well, it's too big for me, so I'll just change it to 20 millimeters. 2 centimeters should be enough, right? So we have a little bit of the font there. Okay. Keep in mind, like we just reverse X and it flips the Z value quite well. So that's what we have so far. We have our numbering, and just make sure that your letters and numbers don't extend beyond the polygons. You don't want that to happen. But it seems to be okay. Right, so we have our text. Now it's time to construct an actual geometry, and I want this text to go in, right? So this text needs to trim out like the portion of this surface. Let us do that. I'll just to make things simpler, I'll take the surface, another surface component, and kind of drag it out here just so that my text and surface is near each other. And what I'm going to do is, instead of using trim, I will actually get the wires, B-rep wireframe of the surface. So I have the perimeter here, and I have my text curves. I will merge them into one big happy list, or multiple lists actually, and I'll use boundary surfaces on it. And that should technically, okay, that doesn't work. Why doesn't it work? Okay, after a little bit of investigation, I noticed that here, our data tree, our original data tree, because we're using the checkerbox pattern, right, and we're removing half of the panels. The naming of the branches is, we are missing branch number 0, we have branch number 1, we're missing branch number 2, we have branch number 3, we actually have branch number 4, but we're missing branch number 5, so it's all kind of messed up. While here it's clean, you know, it's like 0, 1, 2, 3, 4, 5, 6. So we need the text to follow the same logic in terms of branch naming to the wireframe data tree. And this is why I said that this is going to be a more advanced tutorial. So I'll use match tree, and I'll match the text output to my brep wireframe. And now my text output is placed in correct branches. That. Bam. So now after merge, I can use boundary surfaces here, and I get the clean the clean output, as you can see here. Actually, let me hide this just so that you can see better. So now all of these are kind of holes in my, like the top of my panels. Okay, so we have that going on. Now continuing on, I still need this text to be extruded, right? So I will use extrude. Yeah, just simple extrude, I guess, for the matched text, not the original, the matched text. And the direction for extrusion, I'll actually borrow from this from these planes that I got at the center of each of the panels, right? From the frame, or maybe from this plane actually. Yeah, sorry, from this plane. So just to keep things a little bit more tidy, I'm just thinking how I can do this. Let me do it this way, plane, like that, drag it out here. Okay, and now it goes in here. And you can see that it gets extruded by one, always upwards from the element. It's not a lot. How can I extrude by more? Well, I can use amplitude. Amplitude usually works only on on vectors, but in this case, since I'm giving it a plane, it's going to use the z-axis of that plane and will apply amplitude to it and extrude along it. So now I can add amplitude. Let's go for 5 maybe. 5 millimeters. Yeah, that seems reasonable. So 5 millimeters of thickness. But you can see that those 5 millimeters go out, not in. So I want negative 5. Like that. Now they go in, right? And I have a vector. Okay, cool. Now what I'm gonna do is I will take the same text and I'll use boundary surface just on it, like that. And I will push the surfaces that were created downwards so that they meet the end of the extrusion, right? So these surfaces will be moved down. Well, actually, they'll be moved by the same vector, right? So I'll just do this. Bam. That's it. Just kind of reusing the already created vectors. This is becoming a little bit messy, but I think we'll manage. Okay, so we have the base, we have the we have the cap, and we have the extrusion. Let's merge everything into one big happy family. God damn it, missed it. There we go. Let's double check if the naming seems to be fine. The data tree seems to be fine, and we just use brep join on it. Brep join everything up, and now it becomes a single, well, not closed, but a single brep for each of these panels, right? Yay! So we have that. Keep in mind that now we can take the surface, so this was the top surface. The bottom surface is here, right? In the list item, we had the top and the bottom surface. So the bottom surface is still here. So what we can do is we can just say that, well, all of this happens to the top surface, and now we merge them back into one list like this. So the bottom surface just kind of, nothing changes for the bottom one. While for the top one, we do we replace it with this brep join, like that. Bam. Okay, this is gonna be cool. And now, instead of this brep component, we will expand this, and we will, brep goes into, this guy went into the third input. So instead of that, we will be using this new merge thing that we have. And now if I take a look at the custom preview, hide that, I can see that now I have engraved text into my elements, which is good, I guess. We can make this into a cluster. Shall we make I'll show you how to make this into a cluster, because this is a little bit too much for my taste. So I'm going to say that all of this accept the A input, I will want to be able to change this. Also, actually, first let's select everything. So I will not be selecting A, I will not be selecting the slider. Bold toggle I'll keep in the cluster. Extrusion value I'll be not selecting, and merge, no. Okay, so I'm selecting everything here except 2 sliders and 1 panel. And I will group it up, or rather I will cluster it into one node, a single cluster, just to save space. And now I'll move the stuff closer to it. Like that, like that, like that. And now we have a pretty decent small cluster here. So our definition is not too big, and it's easier to kind of orient yourselves in the definition. And I'll just rename the cluster to name, give panels names, or whatever, right? Okay, and now for the other, the blue panels, all I need to do is take this, take this part, let's see, this group, I just take it, copy, paste, I make a copy of it, drag it to where I have the B reps. There we go, that's the B reps that come in to create the blue tiles. So I just connect B reps to surface input here, and the merge connects to D1 input here instead of B reps. So I kind of just run it through here. And here I just need to replace A with B. Hide this, look at the blue one, and that's, now we have the B part also done. So once you've done it, it's quite easy to transfer the knowledge from one element to another. Yay, 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 we are done with the naming. So we will move on to, actually, kind of want to extend this a bit, just so that it's not too kind of condensed. So we are done with the naming, and I will continue on with the orienting after I had some food. So, bam. Alrighty then, let's do some 3D orienting. So I will explain what I want to do before we do it, of course, and then we'll kind of dig in. So here, I have all of these elements kind of nicely stacked into a vault, and if I bake out the structure, add it to the default layer, well, I'm now baking out only the blue ones, but I do have all of these elements separated, all of them are flat and ready to go, ready to be 3D printed and whatnot. But they are rotated, right? They're not flat on the ground, meaning that production of them is going to be tricky. Well, it's close to impossible to produce something like this if it's not flat on the ground. So the way I want to do it is I want to take each of these elements and I want to do orient 3 points and just choose this point, this point, this point. Let's say these 3 points I used for orienting, and I will choose 1, 2, 3 points on the ground, right? And just orient it that way. So I'm laying them out flat and getting ready for 3D printing. So that's the idea. How do we do that? Well, remember where I used list item, and actually let's hide a bunch of stuff so that it's not in the way. Bam, bam. And surface, list item, bam. Remember where I used list item for these 2 surfaces here? Yeah, I'm gonna use that, right? I'm gonna use the bottom ones, right? The bottom surface, I'm gonna use a plane from it and orient from that plane onto world XY plane. So this surface right here, I know for a fact that the bottom ones are the eye output. I already talked about it. If you don't know why it is, pay attention or rewind the video. But we have this, and I can just say, I can just do the same thing. Evaluate, evaluate surface, add its middle point. So / 0, 0, 0.5, 0.5. 0.5. There we go. 0.5, 0.5. I have the middle point. This is not the middle point, but we get it if we reparameterize the input. Now this is the middle point, but we care about the plane. We don't care about the point though. And what I'm gonna do is I will just simply, I'll just simply orient. I'll use orient, and the geometry that I'm going to orient is going to be my initial mesh. My initial mesh, what? My final tiles are going to be the ones that are going to be oriented. My initial plane, so plane from which I'm orienting, is going to be the frame here. But notice how this is a data tree, while this is not. This is a single list. I need to flatten this out. The frame output, I need to flatten it out. If I don't, this will crash, right? So I flatten it out. And bada bing, bada boom. By the way, B by default is world XY. That's why it already works. And it's inside out or upside down. That's not a problem. I can just reverse the plane again, right? Reverse the plane as I did before. If I remember correctly, it's deconstruct plane, reverse the x-axis, construct the plane from origin x and y. By the way, I'm not using z-axis because I really like using construct plane rather than normal plane. That's why I'm not even using the z-axis. Z-axis is calculated from x and y. And we use that instead. And now they're kind of correctly oriented. Nice. And now all I need to do is just separate them, right? Like move them, separate them from each other. So how do we do that? I could do a grid. Shall we do a grid? Let's do a grid. So that is where our B input will come into play, right? Because here, since we're using only one plane for world XY, everything is kind of stacked into one place. But if I do a grid, so let me just, there's no grid here. Okay, sure, let's just go to vector grid, square grid. If I just do a square grid and my size of grid cells, I have absolutely no idea. Let's do 500 millimeters for the size. And then I have like around 100 points. So let's do 50 by 50 or no less. Let's do 20 by 20. So in total, I have 400 grid cells right here. And these are the points on those grid cells, which I can use. I will flatten this output out, and I will connect those points to XY plane so that basically on each of these points, a little plane is created, and I'll use that plane for the B input here. Did I crash it? I think I crashed it. No, I didn't. Okay, it does work. But notice how, at the start, every element is different, right? But then here, all of the elements are the same. That's because I have too many points. I don't have enough elements. I have way too many points, right? So I am going to do one more thing, which is cull. Wait, do we cull? No, we split. Split list. Split list. I will split the list of these planes, XY planes, at a certain index. And that certain index is going to be amount of frames or amount of elements that we have. Doesn't matter which one we use. I will use amount of frames that we have. List length. I measure the list length. I get a number. I plug it into the I input here for the split list. I have two lists, one with 48, the other one with the remaining 393. This is a large number. And I just connect it to the B input here. And now I can see only the elements that I actually need. Double check, 48 elements here. 48 elements here. Okay, great. We have all of them. So that's all we need to do, right? Now I can just say that my extend Y is like 10. Do it like this. So that it's a little bit more compact, but it's basically that. And I have all of these elements, or yeah, all of these elements oriented properly. Add to group. There we go. So that's done. Now for the Y ones, I will honestly, I'll do the same thing, copy paste, and just use the list item from here for the surface input, and use the capped holes, the final output of the tiles for the orient. And now I have outputs for the outputs for the other batch of elements. The only difference here is that I kind of want to move the surface grid to the side, so that these are these are placed side by side to each other. So I think I will do like size minus 500. I wonder. Probably won't work. No, that's stupid. Let's not do that. Instead, I'll do XY. And for origin, I will just create a panel saying minus, I don't know, 5,000, comma, minus 5,000, comma 0. That's the coordinate at which this surface grid will begin, and now they are kind of moved away, right? Just a little hack. This is not, not nice. You can make it much nicer, but yeah, I mean, it works. If it works, it works, right? That's it. We have our elements. I can bake them out, the default layer, and I can work with them separately, and all of them have numbering and so on. So, everything works just as expected. Wait, why are you inside out? I'm selected. Oh yeah, right. We remember some of them are going to be inside out. That's fine. We just need to kind of go into them. Thankfully, since I have under display, I have color back faces turned on. I can see which ones are not completely closed. So I can just zoom in, zoom selected, zoom into them, investigate what's wrong. That nothing seems to be wrong. Ah, there we go. That's a problem. That's a mistake. So I'll just delete this. Try my best to delete it. Let's see if this will help. Okay, almost there. Delete that. Doesn't help. But if we delete the whole damn thing here, delete the surface. Okay, that's a bit better. Now for this one, I will duplicate border, get rid of the top one, select the bottom one, planar surface. Oh, and it makes this kind of a weird thing. Okay. Why is that? Are you not closed? One closed curve. That is super strange. That is super, super strange. Let's try with it being here. Planar surface. Uh-huh. Are you making... Oh, I know. It might be making a mistake in rounding because the text is so small and our... if I go to units, sorry. If I go to units, here the millimeters are set to have absolute tolerance of 1 millimeter, and some of the control points might be closer than 1 millimeter away from each other. That's why it's making mistakes. So I'll just change this to 0.1 for the time being, right? And now if I do planar surface, it's going to do it properly, right? Okay, that is something to be mindful of. And now this is done properly, and now we can join everything up. Yay, now that's done. And I would do the same thing for this one, kind of clean it up. So at this stage, you kind of jump back and forth between different tolerances for units to make it work. I mean, it's a little bit of a hassle, but you need to do it either way. Next up, to actually 3D print it, I'll just draw out my print bed, which is 200 by 200 millimeters. And apparently I need to scale everything down to fit at least a few elements, because this is like a large dome, like a few meters wide dome. So of course the elements are too big. So I'm just going to select this batch here. I'm going to scale them down. Let's say my dome is going to be 0.2. So 1 to 20 size. And honestly, you could use OpenNest, but for something like this, I don't want to make this tutorial longer than it needs to be. I'll just kind of place the elements by eye. Right. Also, they are kind of rectangular, so it's the stacking of them is kind of nice. You would fit quite a few elements in doing so. Okay, that's good enough. Honestly, I will not do anything more. I will select these elements, export, desktop as STL. Hello, STL. There we go, STL, QQQ. Save. 0.01 millimeters, that seems fine. Binary, yes, that seems fine. And here we just straight up, we go to desktop. Where is it? QQQ, there it is. QQQ, we just drag and drop it into Cura. And we see our elements here. I can slice them up. Unable to slice. Why is it unable to slice? Oh, come on, please. Do I really need to come back here? I don't want this to become a long tutorial. All right, we need to run it through. So if it says unable to slice, it's usually something wrong with the mesh. So I would need to come back here and convert these guys to meshes first. So I'll just select them, convert them to meshes, mesh. Least amount of polygons, don't need to have a lot of polygons. Investigate. Let me actually join all of them up into one mesh. What? It's a single closed mesh, super. Export. Again, replace QQQ with the new one, just to make sure that it actually works. File, or let's do the drag and drop method. That will you work? Unable to slice. Oh, I know, they don't fit. Oh my god, I'm stupid. They just don't fit because I'm using the wrong one. Prusa i3 Mark III. There we go. They fit and they get sliced. I just forgot that they don't fit. In 5 hours, I would have this batch of elements, right? And they, as you can see, all of them are flat, laying flat on the ground without any lifting edges. Which means that, you know, at least this portion of them is completely flat. That is literally it. That is literally it. Nothing more to show. I will make this structure into a nice one. I will do a nice thumbnail and call it a day. So, hope you have learned something new. See you next time.